What's up, guys, and welcome to Theory Thursday. Today we're talking about physics. All right, this is going to be a fun short one. We're going to talk about the Harmonic Series. So basically, it's physics. Your string vibrates just like that drop of water that you saw in the beginning of the film when I dropped a drop of water into that glass and then put it in slow-mo and added some cool sound effects for you. Well, essentially, when you see a ripple go, when you drop a drop of water in the middle of a pool and you see that ripple go out, those are basically the same thing as sound waves. You can see this happening on guitar when you pluck a string. You see the string slowly vibrate out back and forth, and that's creating those sounds. But what we don't really hear is the harmonic series that exists on every string. So as you hear one note, you're actually hearing several notes on that one note, which tells your ear that it's real, which is why a synthesized piano that plays the same string in a guitar sound doesn't sound exactly like a guitar, because there's really not a good way to replicate as many harmonic series as we can hear, and they keep going up and up and up. So I've attached a small graph that I found online, and hopefully I'll put the link in the bio so that you can read that page and look at that graph if it helps. But essentially the harmonic series goes like this. You have the open E string, or A or D or any of these strings, and then on the 12th fret you have an octave above it, the same octave as if you were to hold it. And the reason that you have an octave is because it's doubling the frequency. Just like when you drop something into water and that wave comes out and then hits the side of the beach or pond and then starts coming back and hits the waves again, you start doubling the wave size. And as they go back and forth, they triple and quadruple and so on. So essentially, that's what you're doing when you're cutting off these frequencies. When I go like this, I'm getting one big wave with all the other frequencies masked inside that wave. Basically still there, but not as noticeable because they're covered by the giant size of that one big wave. When I do this, I'm isolating the two waves on each side of the octave. So instead of hearing all of the frequencies, you're just isolating that one frequency that already existed because you're just isolating that one faster wave. When I come down to the 7th fret, if I do the harmonic, it's an octave above the 7th fret. And the reason why is the 7th fret is like your initial rock hitting the water. One big string, sorry that was a little loud. One big string vibrating. But when I do that harmonic, I'm actually splitting the string into 3 equal sections, just like that water echoing and coming back. There's this section down here, this section here, and then this section here. And that is an octave above that note, because it's basically splitting this section in half by creating that harmonic frequency. Now the harmonic series spells out a very simple chord that we know. That right there is this. An E chord. Well, starting on the E string. But this is the reason that we understand harmony, because we can hear one string and we can hear a whole E major chord in that string. And as you get further down and create more and more of those waves, they get closer and closer together. So you'll see that the frequencies get closer and closer, and I move smaller and smaller down the neck. So the harmonic series exists because of that water effect, just like you saw in the beginning of the video. And it's what gives us our ear and makes us understand major chords, minor chords, because we can hear them in one single vibration that gets echoed off of whatever it's being echoed off of, whether it's the distance of a string or a wall. And it goes all the way back to Gregorian chant. But it's pretty cool, and it's something you should know because music is math. In fact, I thought about calling this channel that once. Anyway, one last thing before I go, sympathetic vibrations are kind of cool too. So you'll see, I'm going to play just one string and you'll hear the rest of the guitar ring out. But I'll play a chord behind it and you'll hear it ring out louder. And the reason is because all of those harmonies already exist in the note. So when it hits those strings I'm holding down, it makes them vibrate because of sympathetic vibrations. So this is a nonsense chord because it's open. And now, maybe that was a fluke. Let's try it again. And that's your science lesson for today. See you tomorrow for Functional Friday.